Hi, my name is Phil Bagg and we're going to explore conditions that end loops in this video. You'll find more essential knowledge videos at codeit.co.uk/video. You're looking at a semantic wave, which is great for thinking about curriculum sequencing. The idea is to take a complex idea such as conditions that end loops and unpack the concepts until we get to the most concrete examples and simplest meanings. Starting at the red arrow, you can see us doing that on the downward curve from left to right. What is a condition? Everyday examples. At the bottom we have concrete everyday examples of a condition ended by a loop in algorithmic form. Then the curve to the right is where we repack meaning, flow of control, concept in code, how it's part of the indefinite loop family. In the rest of the video we're going to unpick this even more. Conditions end loop are just one type of loop. If you have covered easier loops before, now is a great time to refresh pupils' memory, helping them to retrieve prior knowledge. Before we can use a condition, we need to describe what a simple algorithmic condition is. It can help to check pupils' understanding of a simple condition with a simple question like this. We can identify that C is not a good condition because we can't get it to a yes or no answer. Everyday examples help pupils to think about this through shared memes like, are we there yet? Are we there yet? Are we there yet? Or to view common everyday events through the lens of the condition that stops a loop. It helps to identify the loop and the condition. Here we have used a decision diamond to represent our condition. We have also rewritten the condition as a question to link back to our simple understanding of a condition. We can then demonstrate how this works by talking through the actions while tracing the flow of control on the diagram, going down the orange path every time they have not said boo, until finally they say boo and we go down the blue path, ending the loop. We might say something like, have they said boo? No they haven't. Nod head, wave hand. Let's go down the orange pathway. Have they said boo? No they haven't. Nod head, wave hand. Go down the orange pathway. Have they said boo? Yes they have. Let's go down the blue pathway and we're out of the loop. Getting pupils to act this out with a partner helps to make the learning more active and gives the teachers something to observe to see if pupils are carrying out correctly. Are pupils saying, have they said boo? When they get to the condition, are they going down the correct path? One aspect that pupils struggle with is they often think that as soon as the condition changes, the loop ends, whereas it's only when the algorithm reaches the condition that it is checked. When pupils write their own condition ends loop in algorithmic form, it gives us a chance to check if they understand the concept in one of its simplest forms and is helping them also to develop a possible planning method. Seeing what a condition ends loop is like in programming language is an easier transition once you understand the concept in one of its easier algorithmic forms. The flow of control often acts as a bit of a bridge between simple algorithm and code, because when you see that actually that flow of control works just as well with the code as it did in our algorithmic format, it just creates that connection. Earlier we talked about conditions being questions we could answer yes or no to, but in a digital device we're actually limited much more to very specific conditions. So we're refining the concept here and just helping pupils to realise that actually we're going to have to choose our conditions from ones that the programming language will accept. Let us sum up our knowledge. A condition is a state we can check to see if it's true or false. Conditions can end loops. Conditions are only checked once unless they're in a loop. Conditions lead to two possible pathways, true or false. Conditions are only checked when reached in the flow of control. My thanks to the Everyday Computing team who have published a great repetition trajectory, which I've used parts of here. Do go and look at their research. My thanks also to the others mentioned here for their research and support. As always, all misconceptions and errors are my own. Do get in touch if you have any questions. In Highest, Hampshire inspectors provide resources on every area of the curriculum that you can find in our Moodle. You're welcome to subscribe if you teach in or outside of Hampshire. Thanks for listening.